check if you've ever seen this before on a standardized test, or this is a question you've seen that your students have been asked. I remember seeing this question, something like this question, where it's basically talking about, the growth of a pattern. And so I want you guys to talk with a partner really quick about where you see this or how you see this growing. And so I'm going to put you guys into breakout rooms for a few minutes to let you talk with a partner about how you see this pattern growing. So there are multiple ways that you could see this pattern growing, and everybody can see it differently. So there's lots of right answers here. So just because you think about it in a different way than your partner doesn't mean that that's wrong or bad. It's just that everyone thinks about it differently. So I'm going to put you in a breakout room that has a couple of choices for you. You can use your tools, your pen tool, to draw on the board if you would like to represent how you see the pattern growing. How do you see case 4 looking? So here's 1, 2, and 3, and then in case 4, what would it look like? You can either use the pen tool to draw. I put some boxes down here for you to drag and drop over, so you can make the pattern if you'd like using the boxes. But I'm going to put you guys with a partner, and I'd like for you guys to use your microphones, talk about how you're seeing it grow, right? And then you can move in the breakout rooms. You'll be able to move the slide. We're not going to do it in the main room. So hang on just a second, and we'll get you with partners, and then you can work with your partner to determine how you think it's growing, and then we'll come back together and talk about it. So give me a green check if that makes sense. I'm going to move you to breakout rooms with a partner, and you're going to talk about how you see this pattern growing. If you have a question, just ask in the chat or hop on the mic. All right, I am going to move everyone's breakout rooms with a partner in just a second.
Okay, Taylor, so what pattern do you see?
All right, I see that they start with, they add another row to each pattern. So in number 1, you have 1 box on the top and then 3 on the next level. And the next one, they add another row and add 2 more boxes. And the next one, they add another row and add 2 more boxes. So we can add another row with 2 more boxes to number 3, so we would end up with 5 rows.
I'll move these boxes up here if you want to make it look better.
Yeah, I can do that. I can straighten them out, sorry. Okay, double check me on that. Does that look right to you? It looks right to me.
Yeah, it looks right to me. On the bottom of case 3, there was 1, 2, 3, 4, 5, 6, 7, so this should have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't know if the colors, if those were supposed to, like, represent anything or not.
I have no idea, but yeah. I don't think we had enough otherwise to balance it out.
All right, guys, I brought everyone back to the main room. Sorry if I whiplashed you out of your conversation, but it looks like most people were finished, and I saw some great thinking. You guys were dragging the boxes around and asking great questions. I heard the main room in here was talking about were the colors supposed to represent anything, and to be honest, it was really up to you guys. You could have changed the colors if you wanted to, or if you knew how to do that. Some people, it just makes more sense when you're adding the boxes to drop in new colors, and so I did it that way just so you have some options. But I'm going to show you guys a quick little video about how other people saw the boxes adding in. So as you watch this, think about how your group saw the boxes adding to for case 4, and see if maybe one of the ways that she's going to talk about is the way that you were thinking about it. And it looks like Screencast-O-Matic is also not going to work in WebTour. Okay, putting it on the board for you guys to click on and putting it in chat for you to click on. And then just give me a green check when you're done.
Show you some different ways people think about this. And I've given this problem to many different people. And I think it was my undergrads at Stanford who said to me, or one of them said to me, oh, I see it like raindrops, where raindrops come down on the top. So it's like an outer layer that grows new each time. It was also my undergrads who said, oh no, I see it more like a bowling alley. You get an extra row, like a row of Skittles that comes in at the bottom. Very different way of seeing the growth. It was a teacher, I remember, who said to me, it was like a volcano. The center goes up and then the lava comes out. It was another teacher who said, oh no, it's like the parting of the Red Sea. The shape separates and there's a duplication with an extra center. And I remember this this one as well. Some people see it as triangles. They see the outside growing as an outside triangle. And then it was a teacher in New Mexico who said to me, oh, it's like Wayne's World. Stairway to heaven, access denied. And then we have this way of seeing it. If you move the squares, which you always can, and you rearrange the shape a bit, you'll see that it actually grows as squares. So this is what I want to illustrate with this question. When it's given out in maths classrooms, and this isn't the worst of questions, it's given out with a question of how many. And kids count. So they'll say in the first case there's 4, in the second there's 9. They might stare at that column of numbers for a long time and say, if you add 1 to the case number each time and square it, then you get the total number of squares. But when we give it to students and teachers, high school teachers, and I'll say to them when they've done this, so why is that squared, do you think? Why do you see that squared function? They'll say, no idea. So this is why it's squared.
It looks like
the function grows as a square. You see that squaring in the algebraic representation. So when we give these problems to students, we give them the visual question. We ask them how they see it. They have these rich discussions, and they also reach deeper understandings about a really important part of mathematics. So we actually need a revolution in maths classrooms. We need to change a lot of things. And part of the reason we need to change so much is because research on maths teaching and learning is not getting into schools and classrooms. And I'm going to give you a stunning example now.
For a second, and you can watch the rest of it in a few minutes. All right, so I wanted to share just a few final thoughts with you. I have an exit ticket that we're going to talk about. The exit ticket or ticket out the door, I would put students in individual breakout rooms at the end of the class to work on this. I would tell them to drag their name over to the board, to put their name on the board. And I would also just have them do that before they log out. So their job is to show you, to represent. They can use the boxes, they could draw on the board. and then make sure their name is at the top, and then after they're completed with that, they can log out. And so I would do that at the end of the class as a ticket out the door. But I also wanted to show you guys the Ivy Cam that I talked about a little bit. So can you guys see my video screen over here? So if you want to drag that bigger, you can. That webcam box, audio, video box at the top, you can make it bigger by dragging it down. So you might have to teach your kids how to do that by sharing a screenshot with them on how to drag it down bigger. But that way you can see what I'm doing here. And so I just have my phone sitting on this box. I'll just show you really quick. So my phone is sitting on top of this box on my desk right here. And that is just allowing the camera to be over the top of my desk so that I can show you guys what's happening here. So I just used Skittles. Just got a bag of Skittles yesterday to kind of represent and talk about the different patterns and shapes. And so I know one of the ways that she talked about, you know, that some people see the new rows coming in is sort of like raindrops. And so the raindrops are dropping down on each top of the column to add a new Skittle to the top. So I just wanted to represent that and show you a different way that you could show your students that or talk about it. What did you guys think about that video since we're at the end of our time here? What did you guys think as you were watching that? Did you guys think about it growing in some of those ways? It's pretty creative, right? Definitely my favorite was the Wayne's World. Stairway to Heaven, access denied. So that was pretty funny. And definitely I bet it was a science teacher that thought of the volcano. Right, really thinking outside of the box. And I think that's important to help our kids be able to do. And so that's kind of why I shared this with you guys today. And hopefully this helps you think about that, even if it's not for math. How can you get your kids to think and show their thinking to you? And this way I would end my class with something that I got hopefully from every kid. If I didn't get it from a kid, I could reach out to them, right, and say, hey, I didn't get your answers here, so I'm going to send it to you in email, or put it in your, you know, assignments or something to get it from them. And that way I could potentially take a grade for this, right? I could put this in the grade book if I wanted to. And that would give me some representation, some data to use to be able to kind of drive my instruction on whether this makes sense to them or not. All right, guys.